CIET NCERT presents AudioBook Ganit Prakash Part 2 Textbook of Mathematics for Grade 7.
Page number 1. Chapter number 1. Geometric Twins. On the right side of the page, you are provided with a QR code, scanning which you can reach out to the additional resources to this chapter. 1.1. Geometric Twins. The symbol on the signboard needs to be recreated on another board. Here, there is a picture of a signboard which is rectangular in shape and has a right tick mark inside it. How do we do it? One way is to trace the outline of the symbol on tracing paper to reconstruct the figure. But this is difficult for big symbols. What else can we do? Can we take some measurements that would allow us to exactly recreate this figure? If yes, what measurements should we take? Let us name the corner points of this symbol as given here: A, B and C. In figure, AB is shorter than BC. Are the arm lengths AB and BC sufficient to exactly recreate this figure? Page number 2. Suppose these lengths are AB is equal to 4 centimeters, BC is equal to 8 centimeters. We observe that several such symbols can be constructed with the same lengths. Here we have picture of 4 such symbols with A, B, C marked on the tick marks. To get the exact replica, would it help to take other measurement? The measure of angle ABC along with the two arm lengths AB and BC fix the shape and size of this figure. Can you draw the symbol if it is known that AB is equal to 4 centimeters, BC is equal to 8 centimeters and angle ABC is equal to 80 degrees? These three measurements can help us create an exact replica of the symbol on the signboard. Figures that are exact copies of each other or have the same shape and size are said to be congruent. Congruent figures can be superimposed exactly one over the other. Here we have pictures of two square figures with 4 cutouts at the corners and are placed one over the other. To understand that congruent figures can be superimposed exactly, the two figures are given below. You could use a tracing paper to trace the first figure and superimpose it on the second one. You will find that they fit exactly one over the other. Here we have two circular cutouts and these can be placed one over the other to check that they superimpose each other. Note that while checking for congruence, a figure can be rotated or flipped before superimposing it on the other figure. So, the following pairs of figures are also congruent to each other. Page number 3. Here we are provided with two figures in which we have rectangular corners which can be superimposed on rotating. We also have a picture of two semicircles which can be placed one over the other to understand that they are congruent. Let us get back to the symbol we had on the signboard. Suppose there are two such symbols that look identical and we need to confirm that they are indeed congruent. Can we use their measurements to verify this? If it is known that both symbols have the same arm lengths, can it be concluded that the two symbols are congruent? We have noticed that there can exist several such non-congruent figures with different angles between the given arm lengths. Fixing the angle determines the shape and size of the figure. Thus, if both symbols have the same arm lengths and angle, we can be sure that the figures are congruent. Figure it out. Question number 1. Check if the two figures are congruent. We have pictures of two tick marks. We need to figure out whether they are congruent. Question number 2. Circle the pairs that appear congruent. Here we have 4 different pairs of figures which seem to be congruent. You need to check whether they can be superimposed. One looks like drop of water. Other picture looks like clouds. Third one appear to be of some star, and fourth one of some leaves. Question number 3. What measurements would you take to create a figure congruent to a given A. circle, B. rectangle? Page number 4. Using this, state how would you check if two A. circles are congruent, B. rectangles are congruent. Question number 4. How would we check if two figures like the one given here are congruent? We have a picture of perpendicular lines which we need to check with the 4 given other perpendicular lines whether they are congruent. Use these perpendicular lines to identify whether each of the following pairs are congruent. 1.2 Congruence of triangles. Meera and Rabia have been asked to make a cardboard cutout identical to a triangular frame they have in school. They find that the frame is too big to be traced on a paper and replicated. We also have a picture of Meera and Rabia standing in front of the triangular frame which has a circular cutout in it. Page number 5. What do you think they can do? Measuring the side lengths. Can certain measurements of the triangle be used for this? Using a measuring tape, the girls measure the sides of the triangle to be 40 centimeters, 60 centimeters and 80 centimeters. Then Rabia takes out her protractor to measure the angles. She is stopped by Meera. Meera says, the angles of the triangle are not required. With the side lengths we have measured, we can create a triangle congruent to this one. Do you agree with Meera? Instead of the lengths being 40 centimeters, 60 centimeters and 80 centimeters, suppose the side lengths had been 4 centimeters, 6 centimeters, 8 centimeters. This triangle can fit on our page. Is this information sufficient to replicate the triangle with the same size and shape? If yes, can you do so? Rabia says, if I were to construct this triangle, I would first draw a line segment having one of the given lengths, say 6 centimeters, and then draw circles from each of its endpoints with radii 4 centimeters and 8 centimeters. But the circles would intersect at 2 points, forming two triangles, triangle ABE and triangle ABF. Here we are provided with a picture in which we can find triangle ABE and triangle ABF with AB as the common arm of 6 centimeters. We also have two circles, one passing through E and F and another big circle with center B and passing through E and F. Rabia says, do these two triangles have the same shape and size? If not, then we will not be sure which of these would actually be congruent to the original triangle we are trying to replicate. Page number 6. Examine whether triangle ABE and triangle ABF are congruent. For this, you could use one or more of the following methods: tracing and comparing, taking a cutout and superimposing, or observing that AB acts as a line of symmetry due to the sameness of the act of construction given here with line. We find that triangle ABE and triangle ABF are congruent. From this general construction, we can notice that all triangles with the same side lengths are congruent. Hence, Meera was right when she said that the side lengths are sufficient to construct a congruent triangle. Thus, we have the following result. If two triangles have the same side lengths, then they are congruent. We call this the SSS, that is side 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 condition for congruence. Conventions to express congruence. The two triangles given here are congruent. How can these two triangles be superimposed? Which vertices of triangle XYZ and triangle ABC should we overlap? This has to be done so that the equal sides overlap. Figure out how. We are provided with pictures of two triangles ABC and XYZ, in which we find that AC is equal to XZ, AB is equal to YX, and BC is equal to YZ. Overlapping vertex A over vertex X, vertex B over vertex Y, and vertex C over vertex Z will ensure that equal sides overlap, making the triangles fit exactly over each other. Are there other ways of overlapping the vertices so that the triangles fit exactly over each other? The fact that these triangles are congruent conveys that their respective angles are equal. Angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. Thus, when two triangles are congruent, there are corresponding vertices, sides, and angles which fit exactly over each other when the triangles are made to overlap. In this case, they are A. Corresponding vertices A and X, B and Y, C and Z. Page number 7. B. Corresponding sides AB and XY, BC and YZ, AC and XZ. C. Corresponding angles angle A and angle X, angle B and angle Y, angle C and angle Z. To capture this relation that exists when two triangles are congruent, their congruence is written as follows. Triangle ABC is congruent to triangle XYZ. Here we are beautifully explained here how triangle ABC is congruent to triangle XYZ, as A is corresponding to X is represented with red, B corresponds to Y is represented with green color, and C corresponds to Z is explained with purple color. By writing this, we mean that the first vertex in the name of triangle ABC corresponds to the first vertex in the name of triangle XYZ. The second vertex in the name of triangle ABC corresponds to the second vertex in the name of triangle XYZ. And similarly, with the third vertices in the name of triangle ABC and triangle XYZ. By this convention, it is incorrect to write for these two triangles that triangle ACB is congruent to triangle XYZ. However, another correct way of saying it is triangle ACB is congruent to triangle XZY. Can you identify a pair of congruent triangles given here? Why are they congruent? Here, there is a picture of a rectangle ABCD with BD as diagonal. Consider triangle ABD and triangle CDB. Since ABCD is a rectangle, we have AB equal to CD, AD equal to CB. If the remaining sides of triangle ABD and triangle CDB have the same length, then the SSS condition is satisfied, confirming the congruence of the two triangles. Is this the case? Page number 8. The remaining side is a common side BD. So, the SSS condition holds. Hence, the triangles are congruent. We know the corresponding sides of the two triangles. We have to identify the corresponding vertices. Can they be the following? Triangle ABD, triangle CDB. A corresponds to C, B corresponds to B, and D corresponds to D. Verify this by superimposing paper cutouts of the triangles obtained from the rectangle ABCD, figure 1.1. Here, there is a picture of two cutouts of the triangles obtained from the rectangle ABCD. We find that this correspondence lays the side AB of triangle ABD over the side CB of triangle CDB. But these sides need not be equal, and hence this superimposition will not establish congruence. Identify the correct correspondence of vertices and express the congruence between the two triangles. Figure it out. Question number 1. Suppose triangle HEN is congruent to triangle BIG. List all the other correct ways of expressing this congruence. Question number 2. Determine whether the triangles are congruent. If yes, express the congruence. Here we are provided with pictures having two triangles. One is RED triangle, in which RE is 3.5 centimeters, ED is 5 centimeters, and RD is equal to 6 centimeters. We also have a picture of another triangle JAM, in which JA is equal to 3.5 centimeters, AM is equal to 5 centimeters, and JM is equal to 6 centimeters. Page number 9. Question number 3. In the given figure, AB is equal to AD, CB is equal to CD. Can you identify any pair of congruent triangles? If yes, explain why they are congruent. Does AC divide angle BAD and angle BCD into two equal parts? Give reasons. Here, there is a picture of quadrilateral ABCD with AC as diagonal and AB is equal to AD and BC is equal to CD. Question number 4. In the figure given, are triangle DFE and triangle GED congruent to each other? It is given that DF is equal to DG and FE is equal to GE. Here there is a picture in which two triangles DEF and triangle DEG are joined together having DE as the common side, and DF is equal to DG and FE is equal to EG is marked in the figure. Measuring the angles. Instead of measuring the three side lengths of the triangular frame, if Meera and Rabia measure the three angles, can they recreate the triangle exactly? Suppose the angles are 30 degrees, 70 degrees and 80 degrees. Can we create an exact copy of the frame with this? As we find, we can draw many triangles with these measurements that are not congruent. Page number 10. Here there are figures of three different triangles having the same set of angles, but the sizes of triangles are different. We have triangle ABC, which is small in size, having angles 30 degrees, 70 degrees and 80 degrees. We have two more triangles of different sizes having the same set of angles. These triangles are having the same shape but not the same size. Hence, two triangles that have the same set of angles need not be congruent. Measuring two sides and the included angle. Triangle ABC and triangle XYZ are two triangles such that AB is equal to XY is equal to 6 centimeters. AC is equal to XZ is equal to 5 centimeters. And angle A is equal to angle X is equal to 30 degrees. Are they congruent? To check this, we need to find if there can exist non-congruent triangles with the given measurements. These measurements correspond to the case of two sides and the included angle. We have learned how to construct a triangle given these measurements. Construct a triangle having the above measurements. Compare it with the triangles constructed by your classmates. Are the triangles all congruent? Explain why all such triangles with these measurements are congruent. Thus, when two sides and the included angle of two triangles are equal, the two triangles are congruent. This is referred to as the SAS, side, angle, side condition for congruence. Measuring two sides and a non-included angle. What if two sides and a non-included angle are equal? Triangle ABC and triangle XYZ are two triangles such that AB is equal to XY is equal to 6 centimeters, AC is equal to XZ is equal to 4 centimeters, and angle B is equal to angle Y is equal to 30 degrees. Are they congruent? Can there exist non-congruent triangles having these measurements? Construct and find out. Page number 11. Observing a rough diagram helps in planning the construction. There is a picture of triangle PQR with angle P is equal to 30 degrees, PQ is equal to 6 centimeters, and RQ is equal to 4 centimeters. How does one construct a triangle having these measurements? Step 1. Draw the base PQ of length 6 centimeters. Step 2. Draw a line L from P that makes an angle of 30 degrees with PQ. Here we have a picture in which PQ line is of 6 centimeters and we also have a line L along point P making an angle of 30 degrees. Step 3. Draw a sufficiently long arc from Q of radius 4 centimeters cutting the line L. Here we have a picture in which PQ line segment is of 6 centimeters and we also have a line making an angle 30 degrees with point P. From Q, an arc is drawn cutting this line L at points R and S. How do we find the required triangle from this figure? A point of intersection of the arc and the line L gives the third point of the required triangle. But we find that the arc intersects the line L at two different points R and S. Both triangle PQR and triangle PQS satisfy the given measurements. Page number 12. We have two figures RPQ of triangles having measurement PQ is equal to 6 centimeters, RQ is equal to 4 centimeters and angle RPQ is equal to 30 degrees. The other figure is of triangle SPQ in which PQ is again of 6 centimeters and angle QPS is 30 degrees, but SQ is of 4 centimeters. Hence, we can draw two non-congruent triangles with the given measurements. This is called the SSA, side-side angle condition. We have observed that SSA condition does not guarantee congruence. We have examined cases using two sides and an angle for determining congruence. Can we use two angles and a side? Let us first take the case of two angles and the included side. Two angles and the included side. Triangle ABC and triangle XYZ are two triangles with BC is equal to YZ is equal to 5 centimeters. Angle B is equal to angle Y is equal to 50 degrees and angle C is equal to angle Z is equal to 30 degrees. Are they congruent? Can there exist non-congruent triangles having these measurements? Construct and find out. We have learned how to construct a triangle when we are given two angles and the included side. This construction should make it clear that all the triangles having these measurements must be congruent to each other. Hence, triangle ABC is congruent to triangle XYZ. This condition is referred to as the ASA, angle side angle condition for congruence. In the figure, point O is the midpoint of AD and BC. What can one say about the lengths AB and CD? Here we are provided with a picture in which we have triangle AOB and triangle COD. Line segment AO is equal to OD and line segment OB is equal to OC. Page number 13. We have AO is equal to OD as O is the midpoint of AD. BO is equal to OC as O is the midpoint of BC. Are there any other equal sides or angles? We also have angle AOB is equal to angle DOC as they are vertically opposite angles. We find that the SAS condition, two sides and the included angle is satisfied, and so we can conclude that the triangles are congruent. What are the corresponding vertices? As we need AO and OD to overlap and BO and CO to overlap for the triangles to exactly fit over each other, the corresponding vertices in triangle AOB and triangle DOC are A and D, O and O, vertex common to both the triangles, and B and C. Thus, triangle AOB is congruent to triangle DOC. AB and DC are corresponding sides as they overlap when the triangles are superimposed. Thus, their lengths are equal. Figure it out. Question number 1. Identify whether the triangles given here are congruent. What conditions did you use to establish their congruence? Express the congruence. Here we are provided with pictures of two triangles. Triangle ABC having measurements AB is equal to 7 centimeters, angle ABC equal to 47 degrees and BC equal to 5 centimeters. We also have another picture in which we have triangle XYZ with YZ equal to 5 centimeters, angle YZX equal to 47 degrees and XZ equal to 7 centimeters. Question number 2. Given that CD and AB are parallel and AB is equal to CD, what are the other equal parts in this figure? Hint provided is when the lines are parallel, the alternate angles are equal. Are the two resulting triangles congruent? If so, express the congruence. Page number 14. Here we have picture in which we can find triangle AOB and triangle COD. We have lines AB parallel to CD in which AB is equal to CD. Question number 3. Given that angle ABC is equal to angle DBC and angle ACB is equal to angle DCB, show that angle BAC is equal to angle BDC. Are the two triangles congruent? Here we are provided with a picture in which we find triangle ABC and triangle DBC having the common line segment BC, and angle ABC is equal to angle DBC, angle ACB is equal to angle DCB. Question number 4. Identify the equal parts in the following figure. Given that angle ABD is equal to angle DCA and angle ACB is equal to angle DBC. Here we have a picture in which we can find triangle ABC and triangle DCB having common base BC, and angle ABD is equal to angle DCA. Also, angle BCA is equal to angle CBD. Measuring two angles and a non-included side. The following triangles, triangle ABC and triangle XYZ, are such that angle A is equal to angle X is equal to 35 degrees. Angle C is equal to angle Z is equal to 75 degrees and BC is equal to YZ is equal to 4 centimeters. Are the triangles congruent? Give a reason. Page number 15. Here we are provided with a picture in which we find two triangles ABC and XYZ. In triangle ABC, we have angle A marked as 35 degrees, angle C marked as 75 degrees and BC line segment marked as 4 centimeters. We also have another triangle XYZ in which we have angle YXZ equal to 35 degrees, angle XZY equal to 75 degrees and line segment YZ is equal to 4 centimeters. This is figure 1.2. How do we proceed with this problem? Here is a method. What are the measurements of angle B and angle Y? We know that the sum of the angles of triangle is 180 degrees. So, angle B plus 35 degrees plus 75 degrees is equal to 180 degrees. Or angle B plus 110 degrees is equal to 180 degrees. Thus, angle B is equal to 70 degrees. Similarly, angle Y is also 70 degrees. Thus, we have angle B is equal to angle Y. Does this help in deciding that triangle ABC and triangle XYZ are congruent? We have a picture of two triangles ABC and triangle XYZ with angles marked as angle A marked as 35 degrees, angle B marked as 70 degrees and angle C marked as 75 degrees with BC line segment 4 centimeters. Similarly, in triangle XYZ, we have angle X marked as 35 degrees, angle Y marked as 70 degrees and angle Z marked as 75 degrees with YZ line segment marked as 4 centimeters. These two triangles now satisfy the ASA condition with angle B is equal to angle Y, BC line segment equal to YZ, angle C is equal to angle Z. So, triangle ABC is congruent to triangle XYZ. Page number 16. In figure 1.2, the equalities are between two angles and the non-included side of the two triangles. This condition is referred to as the AAS, angle-angle side condition. As we have learnt that the AAS condition guarantees congruence, we have found that the SSA condition doesn't always guarantee congruence. However, there are some special cases when SSA does guarantee congruence. Here is one such important case: measuring two sides in a right triangle. Triangle ABC and triangle XYZ are right angle triangles such that BC is equal to YZ is equal to 4 centimeters, angle B is equal to angle Y is equal to 90 degrees and AC is equal to XZ is equal to 5 centimeters. Are they congruent? Can there exist non-congruent triangles having these measurements? Construct and find out. Observing the rough diagram helps in planning the construction. We have a picture of triangle PQR in which angle Q is marked as 90 degrees, QR is 4 centimeters and PR is equal to 5 centimeters. Step 1. Draw the base QR of length 4 centimeters. Step 2. Draw a line L perpendicular to QR from Q. Step 3. From R, cut an arc on line L of radius 5 centimeters. Step 4. Let P be the point at which the arc intersects the line L join PR. Here we have a picture in which QR is equal to 4 centimeters and line L is perpendicular to QR at point Q. On this line L, an arc cuts at point P. Triangle PQR is the required triangle. Page number 17. Consider the downward extension of line L under QR. Would the arc from R meet this line downwards as well? As in the case of triangle construction, when the side lengths are given. If so, would this lead to a triangle whose size and shape are different from triangle PQR and yet has the given measurements? It can be found that the other triangle we get here is also congruent to triangle PQR. Why? Therefore, all triangles having these measurements will be congruent to each other. Thus, we conclude that triangle ABC is congruent to triangle XYZ. in the case that we have considered the parts that are equal to their corresponding parts in another triangle are A. The right angle, B. Two other sides, one of which is opposite to the right angle. This side is called the hypotenuse. This is called the RHS, right hypotenuse side condition, and is one more condition for congruence. Conditions that are sufficient to guarantee congruence. From the discussion so far, we can find that two triangles are congruent if any of the following conditions are satisfied. A. SSS condition, B. SAS condition, C. ASA condition, D. AAS condition, E. RHS condition. 1.3 Angles of isosceles and equilateral triangles. Congruence is a very powerful tool for studying properties of geometric figures. Let us use it to discover an important property of isosceles triangles. Triangle ABC is isosceles with AB is equal to AC and angle A is equal to 80 degrees. What can we say about angle B and angle C? Here we are provided with a picture of triangle ABC in which AB is marked equal to AC and angle A is equal to 80 degrees. Construct the altitude from A to BC. Page number 18. We have AB is equal to AC given. Angle ADB is equal to angle ADC is equal to 90 degrees from construction. AD is a common side of the two triangles, triangle ADB and triangle ADC. Here we are provided with a picture in which we find triangle ADB and triangle ADC have the common side AD with angle ADC marked as 90 degrees. We also have side length AB equal to AC, which is marked in the figure. Thus, the triangles satisfy the RHS condition. Hence, triangle ADB is congruent to triangle ADC. This demonstrates that angle B is equal to angle C as they are corresponding parts of congruent triangles. Thus, the angles opposite to equal sides are equal. Can you use this fact to find angle B and angle C? Angles in an equilateral triangle. Equilateral triangles are those in which all the sides have equal lengths. What can we say about their angles? We can use the recently discovered fact that angles opposite to equal sides are equal. Here we are provided with a figure of a triangle ABC in which angle B is marked equal to angle C. Also, the length AB is equal to the side length AC. The sides AB and AC are equal. So, angle B is equal to angle C. Here we have one more picture of triangle ABC in which we have AB equal to BC and angle A is equal to angle C marked in the picture. Page number 19. Similarly, the sides AB and BC are equal. So, angle A is equal to angle C. So, all the three angles of an equilateral triangle are equal, thus like their sides. What could be their measures? As the three angles should add up to 180 degrees, we have 3 into angle in an equilateral triangle is equal to 180 degrees. So, each angle is 60 degrees. Verify this by construction. Thus, just using the notion of congruence, we have deduced that the angles of an equilateral triangle are all 60 degrees. Congruent triangles in real life. Congruent triangles can be observed in various constructions and designs from ancient to modern times. Here are a few examples. We are provided with 4 different pictures on this page. The first one reflects the world famous Louvre Museum in Paris. The second one reflects world famous Egyptian pyramid of Giza. The third one has the picture of a dome design which has so many congruent triangles. The fourth picture is of a rangoli design having many congruent triangles. Page number 20. Here we are provided with a picture of Ravindra Setu or Howrah Bridge, which reflects many congruent triangles. Describe the congruent triangles you find in this picture. Figure it out. Question number 1. Triangle AIR is congruent to triangle FLY. Identify the corresponding vertices, sides, and angles. Question number 2. Each of the following cases contains certain measurements taken from two triangles. Identify the pairs in which the triangles are congruent to each other with reason. Express the congruence whenever they are congruent. A. AB is equal to DE, BC is equal to EF, CA is equal to DF. B. AB is equal to EF, angle A is equal to angle E, AC is equal to ED. C. AB is equal to DF, angle B is equal to angle D is equal to 90 degrees, AC is equal to FE. D. Angle A is equal to angle D, angle B is equal to angle E, AC is equal to DF. E. AB is equal to DF, angle B is equal to angle F, AC is equal to DE. Question number 3. It is given that OB is equal to OC and OA is equal to OD. Explain that AB is parallel to CD. Hint provided is AD is a transversal for these two lines. Are there any equal alternate angles? We are provided with a picture in which we find triangle AOB and triangle COD. We also have side lengths AO and OD marked as equal and side length BO equal to side length OC. Page number 21. Question number 4. ABCD is a square. Show that triangle ABC is congruent to triangle ADC. Is triangle ABC also congruent to triangle CDA? Here we are provided with a picture of square ABCD with diagonal AC inside it. Give more examples of two triangles where one triangle is congruent to the other in two different ways as in the case given here. Can you give an example of two triangles where one is congruent to the other in 6 different ways? Question number 5. Find angle B and angle C if A is the center of the circle. Here we have picture of a circle having center A. We also have triangle ABC inside the circle, in which AB and AC are the radii of the circle and BC is the third line segment of the triangle. Angle BAC is marked as 120 degrees. Question number 6. Find the missing angles. As per the convention that we have been following, all line segments marked with a single line are equal to each other and those marked with a double line are equal to each other, etc. Here we are provided with a picture in which we have different types of triangles in which the side lengths are marked with single lines representing side lengths to be equal. We also have some of the angles marked in order to find out the other missing angles with the help of the properties you have learned earlier. Page number 22. Summary of the chapter. First point. Figures that have the same shape and size are said to be congruent. These figures can be superimposed so that one fits exactly over the other. Second point. While verifying congruence, a figure can be rotated or flipped to make it fit exactly over the other figure via superimposition. Third point. When two triangles have the same side lengths, we say that the SSS side condition is satisfied. The SSS condition guarantees congruence. Fourth point. When two sides and the included angle of one triangle are equal to the two sides and the included angle of another triangle, we say that the SAS side angle side condition is satisfied. The SAS condition also guarantees congruence. Fifth point. When two angles and the included side of one triangle are equal to the two angles and the included angle of another triangle, we say that the ASA angle side angle condition is satisfied. The ASA condition guarantees congruence. Congruence holds even if the side is not included between the angles, angle side condition. In a right angle triangle, the side opposite to the right angle is called the hypotenuse. Seventh point. When a side and a hypotenuse of a right angle triangle are equal to a side and the hypotenuse of another right angle triangle, we say that the RHS, right hypotenuse side condition is satisfied. The RHS condition also guarantees congruence. Eighth point. Two triangles need not be congruent if two sides and a non-included angle are equal. Ninth point. In a triangle, angles opposite to equal sides are equal. 10th point. The angles in an equilateral triangle are all 60 degrees. Page number 23. This page has puzzle time, expression engineer. Draw lines and split the region consisting of white squares into 6 smaller congruent regions. Here We are provided with a picture in which we find 5 by 5 grid with square blocks, and the center block is shaded green in color. We also find picture of small cute kids wondering to solve this puzzle. Chapter 1 ends here.
Ganit Prakash, Part 2. You were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Manju Kumari. Assistance in production, Soumya Malik. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.